Hi, Hannah.
Hello, Sarah.
So I was going to start off by saying that I've read the book and I think it's fantastic. I really enjoyed it. I'm a neuroscientist and I get caught up in my little world in the lab, and so it was really refreshing to kind of see more of a big picture again. And I'm definitely going to take some of the studies that you mentioned and use them in my lectures. So thank you. It's a bonus for me. But first of all, what was your motivation for writing the book?
I put the proposal in 3 years ago to my literary agent and to all the publishers. And it was a time when ChatGPT wasn't quite so prevalent. So AI was definitely something that people were discussing. And it was obviously something that was developing at an incredibly fast pace. But I couldn't predict how it was going to completely take off, which it has done over the last couple of years, I'd say. But what I wanted to really explore was how neuroengineers, computer scientists, have basically used information from neuroscience, from our understanding of human intelligence, of our human brains, in order to inspire the generation of these incredible tools like artificial intelligence. And they've taken understanding of how our own neural networks operate and applied them to artificial intelligence systems. And I wanted to kind of flip the discussion back and say, well, actually, how can we apply this understanding to our own brains? So rather than just trying to outsource our intelligence to these incredible tools that our brains have developed, actually, what can we do to apply this intelligence in our own lives so that we make really good decisions throughout our life? And so that we can continue to flourish and thrive and think intelligently and strategically and plan for the future. And I was particularly interested in this, not just for myself, because I'm obviously, approaching middle age, but also for my parents. How can they use these tools intelligently and make sure that they, have a very active kind of intelligent brain throughout their life, but also for my son. So I've got a 10-year-old boy called Max, who is fantastic, but the world is obviously changing very quickly. So what skills do I need to help nurture in him so that he is resilient in this coming age of technology, so that he can thrive into the future too?
So with the kind of changing technology, and that's kind of completely, I would think, outpacing a bit evolution, like evolution is a slow process. So are our brains kind of equipped to be able to deal with the fast pace, or are we kind of outrunning ourselves with evolution? Can we cope with this?
So I think there is absolutely no question. You're right. There is fast-paced changes occurring in the 21st century. But if we just skip back in time and have a think about what was going on in 21st century BC, it was the Bronze Age, and the written word was starting to become widespread. We were starting to live in almost city-like kind of states, and we were developing tools using metals that could help us, but also we were starting to use them as weapons as well. So there was lots of developments going on back then in the day, and our brains were able to create these changes and keep up with it because we have this incredible, facets of our brain physiology called plasticity. So this is what I studied for my PhD back in the day. I was looking at synaptic plasticity and how our brains can make new connections as we learn from our environment, and how those new connections help us to form memories that create new habits in our behaviour. And this underpins our consciousness, really, our ability to form a subjective view of the world. So we constantly take on board information from the outside world, learn something new, and it creates new connections within our mind that allows us to process information along a new highway in the mind, if you like, and that can create new ways of thinking and new ways of behaving. And this is something that happens all the time in our brains. And I used to stare down a microscope and watch it happening in a petri dish and watch it happening in a model organism and literally see learning and memory take place. And this plasticity, this agility, this flexibility within our minds has basically underpinned our species' survival and our evolution. Way back to the Bronze Age and even before then, Homo sapiens were able to learn from each other and learn from the environment and adapt to it. And today we still have that agility within our mind. and it's so we can keep up when we are the ones that have been almost compelled to create all of these new tools in the form of artificial intelligence. All of this, great technological development has been a result of our human intelligence. I would argue that we can certainly adapt and we can certainly keep up with it as long as we use our brain power wisely. And that's kind of why I wrote the book, so that we can actually continue to adapt and continue to thrive in this new age.
Mm-hmm. So I thought what I'd do is I'd work through the kind of chapters and ask you a bit about each one. The first chapter was on emotional intelligence, and so it's kind of our emotional intelligence ourselves, but also working together. So can you explain a bit more about that and how that kind of collective intelligence might be useful for that kind of future-proofing, keeping our brains agile?
Yeah, so, emotional intelligence and empathy, so the ability to understand our own emotions and to regulate them and to kind of recognise them in other people and see where they're coming from, is this kind of almost soft skill that has been traditionally overlooked, certainly by science and by neuroscientists, and perhaps by society at large. So we used to think that Homo sapiens, that humans, really were very successful because we had logic, we had reason, we were rational beings. The prevailing view, at least in the Western society, was that emotions were this kind of sloppy, hysterical thing that perhaps we needed to quash or try to ignore so that we could exert our decision-making with pure logic. But actually, what we're discovering more and more, probably something that you already intuitively know to be true, but in the scientific community, it wasn't, really properly accepted, that actually these emotions, they send information, they carry information, incredibly useful information to us. They highlight that there's something going on in our environment, or there's some past experience that we need to be aware of, and it should affect our decision making. So fear, jealousy, envy, guilt, all of these emotions have kind of a signature within the brain. And we've evolved to have these emotions to help steer our decision-making effectively. And we now know, scientists are now able to kind of study quantifiably emotional intelligence. And we do that by looking at, for example, playing situations or scenarios to individuals and then asking volunteers to indicate what's going on in that scenario. What are the emotions that are playing out? Do they understand the nuances of that particular situation? Also presenting them with pictures of people with their eyes and then saying, is that person disgusted, hurt, disappointed? It's actually quite a tricky kind of task to do if you don't have a huge amount of emotional intelligence. So it turns out that I'm not particularly good at that task. I probably need some exercise in it. Well, thankfully, we know from these types of studies, and they've also looked at kind of electrical signatures within the brain when you're kind of feeling empathy, when you're recognizing emotions in others. And through this platform of tests, we found out that emotional intelligence and empathy is the number one predicting factor for how successful you will be in life and how happy you are in your relationships and in your life kind of journey. So it's an incredibly important facet of behaviour that hasn't really been properly looked at by scientists previously. We also know that this emotional intelligence, EI or EQ, is basically when we analyse genes and try and find out how heritable that particular trait is, it's got a really low genetic contribution to it. So this is great news. So it basically means if your parents were quite emotionally stunted, shall we say, in front of you, and perhaps you think, oh no, I've got the genes for not being able to empathise or to have emotional intelligence with other people. Well, actually, the genetic contribution is valued at around 10 to 45%. So that's quite a big range because it's quite a difficult kind of behaviour to study, but it's really at the lower end of complex behaviours and its genetic element to it. So what that means is really good news. It means that basically all of us can really help to train our emotional intelligence. And there's some really simple ways that we can do it because environment, obviously, and culture plays a big role in the remainder of that behaviour from 90% to 55%. So what are the simple things that we can do to increase our emotional intelligence? Well, number one is practice a bit of self-compassion on yourself. So if you're feeling a bit upset or you're feeling angry, then just take a bit of time to recognize that in yourself and be kind to yourself and go, well, actually, that's okay. I'm going to pause and just contemplate on that, try and figure out why it might be and how this might be impacting my decision making. Second, there's lovely studies, lots and lots of studies that have shown simply reading fiction is a great way to increase your emotional intelligence. So there's study after study after study that shows that people who immerse themselves in stories, lives of other people, actually helps them to imagine other worlds, other perspectives, other characters, and it actually increases their emotional intelligence and empathy levels. And there's so many studies on this that there's actually a university in America who has started to get all of their medical students to do core components, obligatory core component studies in humanities. So they've got to read books in order to increase their emotional intelligence and empathy because, let's face it, sometimes doctors aren't great at that. So they're really lovely ways of helping to boost our emotional intelligence.
So that's one thing that you do in the book is like at the end of each chapter, you give some pointers on how to do these things and how to like increase emotional intelligence, as you say, or this kind of idea of collaborative empathy. So you work as a group and you pass that on. But I was just thinking, if you like look at the leaders of the world and stuff like that, I'd say that they don't show that much emotional intelligence. Is there any way that like it's all very well and good in our kind of for us to all be good at that, but how can we maybe influence power structures or imbibe emotional intelligence in people who maybe look like they don't have it?
Maybe lacking it. Well, first of all, there's some really lovely studies that I talk about in my book about what happens when people are in a position of power. When they become leaders, then there's some really fascinating neurobiology behind it. So what you see, first of all, is that the mirror neuron circuit within the brain, so it's a circuit of nerve cells throughout the brain that are thought to be implicated in our ability to imitate others, but also have empathy for them. When you're in a position of power, that mirror neuron circuit starts decreasing its electrical activity. So it's less active when you're in a position of power. There's something else that happens that's really intriguing. So leaders, when people are in a position of power, or even if they're imagining being in a position of power, then they get a slightly less sensitive vagus nerve. So the vagus nerve is basically a bundle of nerves that runs all the way from the peripheral nervous system. So there's lots of nerves in the gut and in the heart, for example. And those nerves send a signal via the vagus nerve up to a particular region of the brain called the insula, which is involved in our ability to sense the environment, including kind of taking on board information from other people. And when you're in a position of power, that vagus nerve actually starts to become much less sensitive. So those two mechanisms that allow you to actually demonstrate emotional intelligence or pick up on the emotions of others and the collective wisdoms from people around you starts to get quashed when you're a leader. Why would this be? Well, there's some ideas that perhaps, it's an evolutionary sensible strategy because otherwise you might get too swayed by other people's emotions. And it can sometimes be useful to just be able to make decisions without getting too upset by what's going on in the situation. But obviously, in a lot of cases, when we look at leaders across the world, and I'm looking at particularly one direction across the pond, obviously it can go too far in the wrong direction. So at some point in our lives, we are, each of us, probably going to be a leader of some group, right? It might be, a leader of a school outing, a leader of a party, a leader of, a committee meeting. So what can we do to make sure that our emotional intelligence, our ability to pick up on other people's information doesn't get quashed? Well, there is a really simple thing that we can do to help make sure that our vagus nerve is picking up on all that information from the outside world intelligently. So I'm going to invite you to do a little experiment with me. So I'm going to invite you to exercise with me for 30 seconds. The aim is to get your heart rate up, okay? So exercise in any way you feel comfortable. That was nice. That was good. So now, your heart, my heart's going quite fast because I'm not very fit. Just spend 30 seconds now listening to your nice, strong heartbeat. And there's a wonderful researcher called Sarah Garfinkel. She's done some preclinical trials looking at how little exercises for a few weeks, so not even for a long amount of time, I think it was once a day, helped. In this case, it was patients that had been diagnosed with autism to get in tap with their kind of emotions so that they don't get overwhelmed by them, so they're better able to regulate them, and also to help them to kind of increase their social skills as well. But this is the kind of thing that we could all do within our lives to help us to kind of like listen to all of that information, that embodied cognition, all of that intelligence that's stored within our peripheral nervous system, so that we're not just thinking with our heads all the time and stuck in our own little minds.
So the next chapter, imagination, creativity and flexibility.
Yeah.
So I had two things that I kind of liked from this chapter. One was reinforcing things that I kind of am aware of in myself, like, for example, that you need time and space to think for creativity. So like I'll come up with the idea that solves the problem that I've been stressing about all day at work while I'm in the shower. When I'm not thinking about it, all of a sudden the answer may ping into my brain. Mm-hmm. So there was that's one of the things that struck with this chapter, that you kind of explained that. The other one was about neurodiversity and how kind of embracing neurodiversity and different people thinking in different ways, and how individually we're all different, but that kind of is really useful.
Yes, another behaviour that I think has been not really valued as much as it possibly should have been previously is creativity and our ability to imagine different scenarios and to problem solve and innovate using that creative skill set. And, you know, you're talking about being in the shower and suddenly that's where inspiration kind of comes to you, rather than when you're stuck at your desk kind of really focused on trying to find the problem. Well, that's because there's these beautiful brain waves, which are the slowest frequency of electrical oscillation across your brain cells. It's a really slow rhythmical electrical oscillation. It's called alpha waves, and they're linked to calm creativity. And you get increases in alpha waves when you're doing lovely relaxed things, like, for example, if you're out by the coast having a walk by the beach, or if you're walking in a forest. That's when you get these elevations in alpha waves. Or you could have your eureka moment in the shower because you're relaxing in water there. And so that's, you know, you're in fine company because that's where Archimedes did some of his best work. So there's these beautiful alpha waves that are really important for that creative mindset. And there was a lovely study that was done by Dr. Caroline Deluft. She's based at Brunel University in London. And she basically didn't get people to go for a nice walk in nature. What she did is she actually applied a bit of an electrical shock to one side of the front of the brain to induce alpha wave frequency in volunteers for this study. And she could see that it increased their creativity when they measured them using these different kind of tests that they do in the lab. So I'm not advocating that we all get electric shocks to the head in order to increase our creativity, but I would say that, more time spent trying to relax and also to mind wander. So again, in this very fast-paced world where everybody is quite goal-focused and they're measuring things on their Fitbit and then broadcasting it, and time is categorized and kind of like, you know, chunked so that we can achieve particular goals. Actually, humans have evolved to spend something like 20 to 50% of their waking day just daydreaming, right? It's even more for kids. They have this wonderful propensity for daydreaming. And it's when you have your imaginative, creative thoughts. That's the incubator for ideas. Also, sleep is a really, really wonderful time when we get these creative thoughts. So Salvador Dali and Thomas Edison were very famous for kind of, if they had a particular problem that they were mulling over, they'd just like go and have an afternoon nap, and they'd hold like some keys above a metal tray, and they'd like have a little snooze, thinking about the problem that they wanted to solve. And then they'd inevitably doze off and drop the keys, and that loud clang on the metal tray below would wake them up, and then they'd have a little notebook next to them and they'd write down any ideas that they had. And then again, there's something beautiful about the very early stages of sleep where you get the alpha waves, but also you start to get even slower electrical waves that again help with that creative kind of imaginative thought. And we also know that of all of the primates, humans, we sleep, you know, a fair amount, but not a huge amount compared to some other primates. But we do have a lot of our sleep time dedicated to REM sleep, where you get that eye flickering, and that's when there's a lot of dreaming that occurs. And it's thought that evolution might have whittled away at our total sleep time, but really protected that REM sleep, which allows us to have this beautiful time for visualizing, imagining different worlds and imagining different situations and different ways that we can solve things so that we can innovate. So yeah, that's some of the work on creativity and imagination.
And how about neurodiversity?
Each one of us, has different genetics and different experiences throughout our life. And if you peered into our brains, we'd each have a very unique connectome, because we've got 86 billion nerve cells, 86 trillion connections between them to create this really, really unique brain. So there's no other person on this planet that has the same brain as you. You think in a unique way. You'll see the world slightly different to other people. You'll come up with different solutions to other people. And what we've found time and time and time again is that when you get a diverse group of people together and allow them to freely communicate with each other, that's when the magic happens. That's when they can learn from each other and actually ideas can hop from mind to mind and they can start to innovate and problem solve more effectively. And diversity is key to that. So if you just have a group of clones, innovation is a bit more tricky.
So the next chapter, and it kind of leads on a bit from the thinking about having space for mind wandering and stuff, is about time. So you talk about thinking longer term. But one of the things that struck me on that was the idea of that we can actually slow down time ourselves. I wondered if you wanted to try and explain that.
Yeah, so they got a group of people and they asked them to meditate for just 30 minutes for a week. And then they asked them to watch 2 short documentaries that were 5 minutes each, but they didn't tell them how long the documentaries were. And then they asked them to estimate how long that film was. And the group that had practiced meditation, all of them thought that the film was much longer. Now, what does that say? Does it say that they were expanding time? Or does it say that they were just very, very bored? There is some wonderful mechanisms within our brains that help us to expand our life, actually, through resting. So there's a wonderful protein in our brain that has been very aptly called rest. And in centenarians...
That's people who live till they're 100.
Yes.
Or over 100.
Over 100. They have huge amounts of this rest protein, whereas people that have a much shorter lifespan don't express quite as much rest. What does rest do in the brain? Well, it actually makes those excitations rest in the brain. So occasionally you get these periods where there's nice, quiet, not huge amounts of excitatory electrical oscillations going on across the brain, but there's a bit more resting and a bit more quiet. So that's, again, something that I'm advocating, is that we take a little bit of time to rest so that we can expand our lifespan, actually. And then there's another wonderful study that really, really appealed to me. It was published in Nature, and they were comparing how quickly genes get expressed into proteins in different species. And they found that human cells do it really quite slowly compared to bacteria that really quickly zip along the genes to express the proteins. And they found that this slow pace actually increases fidelity. So there's less likely that mistakes will creep in to that expression mechanism. And so actually things get expressed and copied with a higher fidelity. So again, we're starting to see, at many different levels, whether it's at a transcription cellular level, whether it's at our lifespan level, this ability of ours to expand our time zones and to actually take a bit of a rest and to slow things down seems to be very successful for us as a species and something that we should try and appreciate. And again, when you talk to AI developers, they're actually using that notion and looking at how that happens within our species and trying to emulate it in the AI that they're developing so that they can actually create that facility for rest and for wisdom and reflection to occur within the AI.
Moving on to the next chapter is about adapting to uncertainty. And there's an experiment there that you talk about where if you'd rather get an electric shock than wonder whether you're going to get an electric shock. So you'd much rather take a punishment than be sitting there worrying about punishments. And that's another thing, that kind of uncertainty in the world and stuff like that is something that I think that we all feel every now and again, or kind of job security stuff like that. So do you want to talk more about that? Because I found that fascinating.
Yeah. So this wasn't a study that was just done on Masochists, sadists?
No.
Which one is it? But this is like, normal volunteers. And what they found was that people would rather have the certainty that they were going to be hurt, so it was either an electric shock or to take a financial punishment. So they would rather have the certainty that they were going to take the hit rather than just sit there and wait and not know whether it was coming or not with a 50% probability. And there's many studies of this ilk that shows us that not only have we evolved to not enjoy any threats from the environment and to try and keep ourselves safe, but we've also evolved to find uncertainty and ambiguity deeply uncomfortable and perceive it as a threat in itself, sometimes even more so than the reality of the actual threat. Why is this? Well, if we look at how our brains operate, we get something in the region of 11 million bits of data that enters our senses every single second. And we actually only able to process something like 40 to 50 bits of data per second. So that's a minuscule proportion. So there's lots of information from the outside world that we just discard, that we're not consciously aware of. And the reason for that is that, I was kind of alluding to it earlier, our brains are really metabolically demanding. In order to produce all of those electrical oscillations that whiz across the brain so that we can think and feel and process information from the world around us, each neuron creates 4.7 million ATP molecules every single second. And to sustain a really concentrated thought, it's 3.5 times that. In each day, our brain creates and uses 5 to 6 kilograms of ATP, which is the currency for energy. Every single day, that's how much ATP we're creating and using by our brain. And they don't want to have to use any more because otherwise they would just blow a fuse. They would just be like, whoa, too overwhelmed, this is too much. So we take shortcuts in our information processing. And in order to do that, basically create habits in the way that we think. And that helps us to conserve a little bit of energy in this already energy metabolically hungry brain. So all of these habits that we create, all of these rituals, all of these things that you do on a daily or a weekly basis basically helps your brain to conserve energy. And it's a very, very sensible strategy. When we have to deal with uncertainty and ambiguity, when there's a new situation that's coming in, whether it's, geopolitical instability, whether it's, threat of the Middle East, whether it's the next pandemic or the last pandemic coming in. So your routine gets disrupted. Your brain has to work really hard in order to compute this new situation. And it's basically like asking your brain to go to the gym and do a really, really, really hard workout, and you don't really like it. It feels very uncomfortable. But there's ways that we can increase our tolerance for uncertainty and ambiguity, because no matter how much we try to embed habits in our daily life, it's a fact of life that we will always have uncertainty in our day. We never know what's going to happen tomorrow. We don't know what's going to happen next week, next month, next year. We don't have control over everything. So uncertainty is a certain factor of life. And so we do need to be able to keep up with it, even though our brains find it quite unpleasant. And we need to be able to see possibility in that uncertainty rather than just cower and think about the worst case scenarios. So again, we need to exercise our skills in imagination so that we can imagine a new situation, new habits that we could form that could be positive for us in the face of ambiguity and uncertainty. We need to make sure that our brain has the energy so that it can do all of that work to make new connections so that we can think in new ways when faced with uncertainty. And there's really lovely things that we can do there. So the reason that I went on and on about ATP, does anyone know what the kind of power stations of the brain are? And the body as well. The little organelles that help to create that ATP. Mitochondria, yes, I love mitochondria. And what I wanted was for the publishers to hide a little mitochondria in the cover, but they didn't. But it is genuinely a book dedicated to mitochondria, because mitochondria and the ability to produce this ATP really underpins all of the skills that I'm talking about. So our ability to have emotional intelligence, to empathise, to be able to imagine someone else's way of seeing the world, to be able to be creative, to innovate, to be able to adapt in the face of uncertainty, and to see possibilities rather than doom. Our ability to even think clearly and with precision, all of this, the linchpin of all of it, is really our ability to properly fuel our brains and create enough energy for that agility and flexibility in our minds so that we can continue to thrive and adapt. And having healthy mitochondria within our nerve cells is key to it. So what can we do to help increase our mitochondrial health? These are all lovely things that you know intuitively to be true. So, exercising. We know that exercise basically sends a signal to the mitochondria to say, we're using much more energy than we thought. We need to multiply under a process called mitogenesis so that we can create more energy. It's a bit like, the UK government deciding they're going to build many more solar panel farms or nuclear power stations because, we're using more energy. It's the same thing that happens within your brain and your body. So if you exercise, you increase the number of mitochondria and you increase the potential for your ability to create energy to help you to think and to move. Also, if you sleep really well, that helps us to clear away any mitochondria that aren't functioning properly, and it also helps to clear away any toxins that accumulate during that process of producing energy, because our bodies are really good at producing energy, but not all of it is clean energy, and there's toxic byproducts that need to be mopped up. So sleep is really good, exercise is really good, and then also eating healthily. So making sure that we are eating in a way that is creating the right fuel for our mitochondria to then create that ATP so that our brain can think with agility. By that, I mean decreasing processed sugary foods and increasing the amount of vegetables that we have, but also protein, really good for the mitochondria.
Just going back to the thing about uncertainty, is one of the things that you talk about in the book is how people shortcut to their own echo chambers, and that's where people believing conspiracy theories and things.
Yeah, so first of all, we know that when people are feeling stressed, very stressed and overwhelmed by a particular situation, they are much more likely to land on a conspiracy theory because it helps their brain to provide some explanation for the situation that's going on. It might not be the accurate explanation, but at least it allows their brain to go, okay, this is the answer, fine, I don't need to process that information anymore. And stress seems to, or people feeling that stress, actually veers them much more towards that route of wanting to land on a conspiracy theory. So anything that we can do to help individuals in our society to not feel that stress and to be aware that actually emotions are quite contagious. So, if I am very stressed and feeling a threat in the environment, there'll be a little chemical signature in my sweat which will be given off that you might not be consciously aware of because I'm not that stinky, but it will send a signal via your nose up to your brain, and it will prime your amygdala to think, oh, hang on, there's a threat in the environment, I should be extra careful. And there's some people that are so sensitive to feelings of stress that then they're actually much more likely to kind of land on that conspiracy theory, and rather than actually think critically and properly evaluate the information. So making sure that we help to lower stress levels and we're aware of our own emotions and we're not transmitting like a contagious fear that can ripple out across the society. And throughout civilization there's been propaganda, right? Governments have made use of this type of response that we have to manipulate democracy. But just being aware that, this mechanism exists within us. Anything else that we can do? I think, being curious. So always asking questions. And I've got friends that believe in some very particular things that are not what I believe in, but I'm able to have conversations with them and really investigate their thoughts, right? They're coming from somewhere. They're coming from some point of view, and there's something that I can learn from them. Chris and Uta, they're a formidable couple in science that have done some groundbreaking research. They've looked at what happens when you get groups of people communicating freely. Each one of us has got an inaccurate representation of reality because we can't analyse everything in the environment and we take shortcuts. But when you get people to talk freely amongst themselves, those biases can get evened out and they can create a much more accurate representation of reality. So just chatting to people, just asking questions, just reining in your own emotions, your own emotional result, your own kind of biases that exist within you, and actually having an intelligent discussion where you're actually really interested in where they're coming from will probably help you, and it will probably help them as well.
Moving to the last chapter is about global citizenship and AI. So ChatGPT, I looked it up for this, but it's only been around for less than 3 years, and it's already, AI has just infused everything. I can't look on my phone without there's a little button at the bottom that will give me an AI explanation of everything. It's weird. It's just got everywhere. But there is really a thing that AI gives us shortcuts and gives us answers and stops us. Like, there's evidence now that people have stopped thinking a bit, because I don't know, teaching in universities, it's kind of worrying because you do see it creeping into stuff. So how can we learn to use it and not detrimentally to ourselves? Kind of what should our relationship with AI be?
So there was a study that was published, and it kind of went all over the news across the world. It was really picked up. They showed a brain of somebody who used ChatGPT and a brain of somebody who didn't. And there was basically no activity in the brain of the person that used ChatGPT. And this went around the world. It circulated around the world. I have to say, it was a study done by scientists at MIT, so it's a fairly reputable place. And it was a really interesting study, but it had its limitations. So there was a number of limitations. So, for example, it was asking people to either create a story and evaluate a bit of text using ChatGPT help, and they did that 3 times, or just using their own knowledge. And then they switched that group that was using ChatGPT and asked them to do this task that this group had already had a practice go on for 3 times. And then they both basically did the 4th set of task. And they directly compared this group to this group. And it was quite a very, very small sample group as well. And obviously we can adapt. Once we practice something, this particular skill that this group had, they got better and better and better at it. And they were able to use their brain much more effectively at it, as you would expect. So it wasn't really comparing correctly. So many more studies need to be done in this area. I would say we were all quite worried back in the day, probably in the Bronze Age, 21st century BC, people were a bit worried about like the written word coming in widespread use, and how that would stop people from discussing and debating. And actually back in Socrates' day, he used to vocalize concerns about this. And the only way that we actually know is because one of his students, Plato, wrote it down, ironically. Flip forwards to today, or actually look at what happened in the 1970s. Calculators, little handheld calculators, came into the widespread in schools. And so suddenly you were able to do these mathematical computations using not just your brain, but you had this like tool available to you. Now that's brilliant. The students would have been like, woohoo! Apart from the educational system went, oh, hang on, we've got these incredible tools. We are going to increase the expectations of our students and give them much more complex problems to solve, much more complex calculations. And that's what they did. That's how they've responded. To the point that my nephews, when they went to primary school, the teachers had to call in the parents. This is in Bristol, in the UK. They had to call in the parents to give them a lesson in maths, basic maths, so that they could keep up with the kids. Genuinely. So it's not that the maths has actually been dumbed down with this new tool that is coming in. And I would suggest that perhaps what we need to do, ChatGPT, if it's only been around for 3 years, we need to ramp up our expectations of students, and maybe, I hate to say it, writers, so that, and it actually helps us to use these tools in new ways to advance our thinking and actually improve the cognitive output that we actually have. There's some wonderful studies that have been done using AI tools in a fantastic way, and my examples come from biotech largely because that's the field that I work in. But back in 2019, there was a group of scientists, again from MIT, who wanted to look at antibiotic resistance. It's a big problem that's facing the world, especially because we're, moving around the world and we're sharing our bugs, and lots of us are using antibiotics. And so they wanted to find a new agent that didn't have resistance and didn't have lots of toxic side effects. And they used AI to trawl through existing antibiotics. And then they used AI, they put that on the training data for the AI, and then they put it to trawl through a catalogue of 60,000 molecules that had all been approved with the FDA, with a single goal of trying to find a new agent that would be antimicrobial. And they found a new agent. And the scientists looked at it and they did some tests, and they were like, bloody hell, it works. And it isn't, it's not causing toxicity in humans. And then they were like, but how does it work? They genuinely couldn't figure it out. Didn't follow any of the known mechanisms of action for antimicrobials. And then they reverse engineered it, and then they figured out how it worked. And it opened up a whole new reality, a whole new route by which they could actually tackle this problem. So it opened up their perception. There's other examples where a colleague at Cambridge has used AI to help create new drugs for rare diseases that pharmaceutical industries normally wouldn't bother to investigate because the incidence of patients that it affects is so small that there's no financial return for it to do all of the standard laboratory tests. But they used AI and they came up with a new drug, and it's in clinical trials. So these are really wonderful ways that we can use AI to tackle problems that otherwise we possibly wouldn't be able to find a solution for.
So we shouldn't be scared of it. It's just the new calculator of the day, really.
Yeah, exactly. And, you could use it to write, I don't know, something that we did is we wrote boobless in the calculator by putting the numbers in and then flipping it down and thinking that's really cool. But there's other things you can do with the calculator too. And similarly, you can use, these new tools to create a little cartoon cat character of yourself and share it on social media. Or you could do something else with it. Or you could do both.
We're just about out of time on questions, but I've got one last question. So 21st century brain, we're only a quarter of the way through the 21st century. So what do you predict is going to happen next? What are our brains going to look like, or what are we going to be doing by the end of the century?
I start the book off actually talking about how a number of researchers think that we're undergoing a massive evolutionary transition to create more of a interconnected hive mind or an organic supercomputer. And we've basically developed all these technologies like the internet, like the written word before that, like encyclopedias, like social media, like artificial intelligence that allows us to share our perspectives, to share vast data sets of information, and to share our perspectives of the world, right? So we're getting much, 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 much more global and interconnected. And we have been compelled to develop these technologies that are assisting with that. And I think what we're probably going to see is that movement towards creating a hive mind is what's going to predominate over the next 75 years. That would be my hunch. And I think, our ability to connect with each other, not just using technology, our ability to have emotional intelligence, to actually pick up on information from other people in person is going to be, again, something that we're going to be valuing as well more and more and more, because it is part of our ability to share information with each other and to connect as a species.
You talked about ATP and creativity. So is there a correlation between increased or decreased levels of ATP with very creative people, writers? Is there a correlation between that with people, say, that might have some mixed bag constellation of diagnosis of dementia, be that Lewy body and or Parkinsonisms, whether there's any correlation with ATP levels in those kinds subsets of people?
So I was talking about alpha electrical activity, and brain waves. So no, alpha waves, if you elevate them artificially or if you elevate them naturally, actually increases creative output. There are some people who seem to be very creative naturally, and they might have a genetic predisposition to it. So I interviewed somebody who's got hyperphantasia. So they've got almost like a visual imagination. They can imagine everything and remember it as well, as compared to people with aphantasia. So they literally can't visually, if they wouldn't even be able to recognize their mother in the street because they don't recognize the face. But particularly, I also talk to people who have been diagnosed with ADHD. Now, ADHD is linked to entrepreneurialism and not just having imaginative, creative ideas, but also being able to enact them as well. There's a higher incidence of people that have ADHD-type behaviours that are very successful business people. And that requires you to think outside the box, to think laterally, to think creatively. And there's differences within their dopaminergic system, generally speaking. There was a lovely study that was looking at, in a virtual reality setting, they were looking at different people and asking about different behavioural traits that they might have. And then they had a task where they had to go and kind of explore a virtual reality environment and try and pick blueberries from a bush. I think it was blueberries or some kind of berries from a bush. And those that had ADHD type traits were much more likely to leave the bush that they were standing in front of and go and explore out with the idea that perhaps there was another bush that might have more berries on. And they found that actually those people that had those traits did explore out much more. They had a much more exploratory kind of outlook, and they actually collected more berries as well, so they were more successful. Did they have increased alpha wave activity too? I don't think they studied that, but they should have done.
We've talked all night about the brain with some reference to the body and intelligence in the body, but I wonder if there is any studies or how much we're studying the connection between the heart and the actual organ of the heart and the brain, and how working not just on keeping our brain active but on developing even more of that connection, the two-way connection between the two, can help us develop even more wisdom and more ability to adapt and evolve.
Yeah, so that's a really good question. So you sometimes get that heart flicker or a gut feeling about something. It's exactly that. It's picking up on that nervous system that lives within the heart or the gut. And the vagus nerve is central to passing that information to the insula of the brain. And that insular brain region, when it's really active in some individuals, it means that they are very in tune with their environment. They're able to pick up on all of that extra information from the world around them, and sometimes their decisions making is better as well. In fact, one of the earliest studies in this area came from a guy called John Coates, and he was a financial trader back in the day on Wall Street, which is an unlikely kind of group of people that you might be looking at, like that embodied cognition and that ability to feel with your emotions. But what he found was that traders who were had a very good heartbeat detection ability, the thing that we were doing earlier, and had a nice sensitive vagus nerve going to their insula, actually made better trading decisions, trading decisions when they were surrounded by other people. And actually that heartbeat detection ability could predict how much profits they made during the financial crash. So even in the financial world, it pays to be in touch with your emotions and other people's.
I heard no mention of cognitive bias tonight, like looking at maybe how we can collectively better deal with our cognitive biases and be aware of them. Is that something that you studied?
Yes, it is. Within my book, Joined Up Thinking, the Science of Collective Intelligence. So there's lots of work there on biases and how our brains do take those shortcuts that can create quite erroneous senses of reality, and what we can do to help circumnavigate that.
Going back to your point about leaders, something changes in leaders because they get the power.
Basically, their ability to emotionally connect with other people is diminished, and they're less able to pick up on intelligence from other people and to view the world from someone else's vantage point. I think there's certain people that are driven to those leadership roles, right? No doubt. But actually, scientists have done studies on healthy volunteers, including monks, and found that, all of us have within us the propensity to become a bit of a dick when we are a leader. Sorry about that. I could have said another word, but that would have been really rude.